Good morning, thank you for coming to this webinar. An honor to be here with you today. Let me introduce myself. My name is Krisa Delva Sutanto. The purpose of the presentation is to describe the roles of zinc, vitamin C, and vitamin D in immune system. I would like to present this topic with my partner, Yohanesa Mulandari. First of all, I am going to explain about vitamin D. This figure shows vitamin D metabolism under normal condition and in extracellular tissue. Vitamin D, which was previously in the form of 25-hydroxyvitamin D, will be activated by the enzyme 1-alpha hydroxylase or CYP27B1 in the proximal renal tubule. This enzyme induced by parathyroid hormone, which then convert 25-hydroxyvitamin D to 1.25-dihydroxyvitamin D. The 1.25-dihydroxyvitamin D will be released in the blood vessels and also induce vitamin D24-hydroxylase to become less active metabolite. There will be an increase in serum 1.25-dihydroxyvitamin D to suppress parathyroid hormone synthesis by the parathyroid gland. It aims to form bone-forming osteoblasts and bone-resorbing osteoclasts in increasing the uptake of calcium and phosphate in the intestine. 1.25-dihydroxyvitamin D also stimulates fibroblast growth factor 23, which is suppressed by CYP27B1 activity. Expression of this enzyme was also found in extracellular tissue, which is thought to be synthesized 1.25-dihydroxyvitamin D in this tissue. Vitamin D increases the production of interleukin-10 and the chemokine CCL22. Suppression of interleukin-12 by dendritic cells, leading to differentiation of T cell towards T helper 1 and upregulation of interleukin-10. Vitamin D3 also has an effect on major histocompatibility complex 2, altering the ability of dendritic cells to bind to T cell so that dendritic cells lose co-stimulatory molecules, increase T regulator cells, and cause T cell to become energetic. Vitamin D also inhibits the differentiation of B cell into plasma cell, B cell proliferation, and the production of immunoglobulins such as IgG and IgM. This picture shows the role of adequate vitamin D on the immune system. Under adequate vitamin D status, the synthesis of 1.25-hydroxyvitamin D maintains a state known as tolerogenic immunity with a balance toward T helper 2 and T regulator. In contrast, instead of insufficiency, the immune response tends to be more toward T helper 1 and T helper 17 rather than T helper 2 and T regulator. The daily requirement of vitamin D is about 15 micrograms per day or is equal to 600 international units per day. Food sources of vitamin D, especially from dairy products and animal protein such as milk, yogurt, fish, egg, and also plant protein such as mushroom. Then the next discussion will be explained with my partner Yohanesa Mulandari.
Hello, my name is Yohanesa Mulandari. What I'd like to present to you today is about zinc that plays an important role in the immune systems, affecting both innate and also adaptive immune cells. From this picture, we can understand how the effects of zinc deficiency, including thymic atrophy, lymphopenia, impaired cellular, and antibody-mediated immune responses. Zinc has a multitude of other pro-antioxidant functions, which may also be contributing to elevated ROS levels during a shortage of zinc. During zinc deficiency, impaired function of PNN in vivo was reported, resulting in decreased activity of phagocytosis. Additionally, increased maturation into macrophage was observed after zinc depletion, suggesting that low zinc status promotes differentiation of monocytes. This is due to decreased T helper type 1 cell-mediated secretion of interferon that caused by zinc deficiency that lead to impaired thymine activity and also apoptosis of T cells. It has been postulated that reprogramming of the immune systems occurs during zinc deficiency, such as shift from adaptive to predominantly innate immunity, and immediate host defense would be accompanied by a decreased requirement for communication between innate and adaptive immune cells by cytokine. Food sources of zinc consumption can reverse the negative effects of zinc deficiency that widely found in tuna, egg, meat, chicken, and also plant protein such as mushrooms. 30 milligrams a day and also 10 milligrams a day is needed respectively in men and women.
Now we continue to discuss about vitamin C. In innate immune system, vitamin C causes migration of neutrophils to the site of infection. Furthermore, when inflammation occurs, interleukin 8, leukotriene B4, complement C5a, and neutrophils will go to the site infection, and this called chemotaxis. Neutrophils have chemoattractant receptor. Therefore, in vitamin C deficiency, immunosuppressive mediator such as interleukin 4, interleukin 10 will increase. Vitamin C can also act as a phagocytosis and killing bacteria. Reactive oxygen species, or ROS, are produced during the respiratory burst to kill pathogen. The role of neutrophils here as the first line of defense to neutralize ROS. Intracellular granules are mobilized and fused with phagosome. One of the components of in ADPH oxidation will accumulate in the phagosome to form superoxide. Then, by the superoxide dismutase, it will be split into hydrogen peroxide. Vitamin C can act against capcase-dependent apoptosis following neutrophil activation. Because neutrophils are the first line of defense, neutrophils can join and expel bacterial molecules and DNA to produce neutrophil extracellular traps, or NET. NET is a type of cell death called netosis. Lymphocytes are part of the adaptive immune system. There are three types of lymphocytes: T cell, B cell, and natural killer cells. Some kinds of T cells include T cell receptor that is responsible for binding to major histocompatibility complex on antigen-presenting cell. T helper 1, like cytokine, is secrete interferon gamma. T helper 2 secrete interleukin 4, 5, 13, and TNF-alpha. The role of vitamin C is inhibit T helper 2 differentiation and enhance T helper 1 response. And the last is cytotoxic T cell that prevent autoimmunity. Vitamin C also plays a role in the formation of immunoglobulin. As we know, immunoglobulin, or Ig, is included in B lymphocyte. There are some kinds of immunoglobulin. IgM is the first immunoglobulin in the blood at the time of infection. IgG indicates long-term protection in blood vessel. IgA is immunoglobulin that fights infection on mucosal surface such as respiratory system and digestive system. And the last is natural killer cells. It is categorized as a group 1 innate lymphocyte or ILC, and respond to wide range of pathological changes. Vitamin C increases natural killer cell proliferation. Vitamin C is widely found in fruit and vegetables. Guava, kiwi, strawberry, orange, tomato, lemon, and pepper, also broccoli, are the food sources of vitamin C. 90 mg per day and 75 mg per day of vitamin C is needed respectively in men and women. That's all for us. We hope this presentation has given us new insight on the roles of vitamin D, zinc, and vitamin C in immune system.